Looks like we have a small crowd for this, so if you guys want to shuffle over, that'd be great. Otherwise, I'm going to be looking around a speaker to talk to you guys. If you want to remain anonymous, you can sit there. Just there's a big old speaker between me and you. So, I'm here today to talk to you guys about containers and what Microsoft is doing about containers and container technology. So before I get going, I always like to know something about the people I'm talking to. So a couple of questions that I have for you guys. How many of you have actually played hands-on with Docker? Like have actually tried it out, used it? Okay, we have one person. That's not hugely surprising. So I'm actually glad to hear that. I was worried that I was going to ask how many people have played with Docker, and everyone would put their hands up, and I'd be like, oh, I'm going to be covering a lot of boring material. So how many people here have Linux in their environment somewhere today? Fine. How many people would say, I have Linux, but we're primarily a Microsoft shop? Okay, also reasonable. So thanks. As I said, I like to know the audience I'm talking to. So now, quick introduction. I'm Ben Armstrong. I'm a program manager at Microsoft. Usually when I come out to events like this, I'm talking about Hyper-V. And that's what I'm going to be talking about tomorrow. But in this session, I'm here to talk about containers and what Microsoft is doing with containers. So what are we doing? Containers is an interesting technology that we've had a number of incubation efforts on, and that we've been looking at internally for quite a long time now. And just recently, it's a concept that's been getting a lot of traction in the Linux community and in the DevOps community. And we were watching this from the Microsoft side of things, and so we're like, you know what? We need to finally come out and deliver some technology here. And last October, we had an event where we made a set of announcements where we said, OK, we are going to be delivering something called containers as part of the next release of Windows Server. We're going to be partnering with the company Docker to allow Docker to use Windows Server. We're going to provide support for the Docker Hub and for the Docker engine. And we came out and we made this announcement and felt good about ourselves. And got a good press reaction. And when we went out and talked to IT pros, to Fabric administrators, to our usual audience, they primarily had one question. What are containers? What on earth are you people talking about? And that was kind of an awkward and embarrassing moment for us, because this is the classic mistake that engineers tend to make, is we go off in the closet for a period of time and work on a bunch of technology, and then we come out and start talking about it, and we forget that the rest of the world hasn't been involved in this process. And so we've made a lot of realizations and learnings, and we haven't shared them. So a large chunk of what I want to do today is to help you guys to understand what are containers and start to get your head around what they can do for you and how they're going to change the way you run business. Because to be clear, we do think that this is a big deal, and it's going to change the way a lot of people are running their infrastructure. So first and foremost, let me show you a demo of Docker. And this is going to be Docker running on Linux using Linux containers. So I'm actually going to show you two demos here. The first one, I just have an Ubuntu virtual machine running on Hyper-V. And I'm going to log in. And here's where I hope I type my password correctly. The annoying thing is I'm going to use Linux virtual consoles to log in 3 times. You'll see why later in the demo, but it does mean I have maximum opportunity to mistype my password. Okay. So I have 3 logins. Let's jump over to the first one. And I'm going to run a basic Docker command. And before I run this, just to step through, I'm running sudo, so it runs as an administrator. Docker, which is their process, their executable. I'm saying run something for me. The -i-t is basically the way of saying do this in an interactive mode. Don't do it in the background. The Ubuntu is the name of the base container I want to use. I have an Ubuntu container. And then date is the command that I'm asking it to run. So I'm basically saying, Docker, can you create a container based on my Ubuntu base package and run the date command for me? So it's going to ask for my password again, and it's going to run the date. And you're probably looking at that and going like, wow, that's really exciting. You just figured out date. Woo! Great demo, Ben. But the thing I'd like to highlight is what actually just happened was they created an entire separate Linux instance and container, ran a command, and returned the results in about a second. You can't do that with virtual machines. And this is one of the big things about containers. And just to highlight, like, run it again. Blip. That was a new container, created, command run, results gathered, returned. And this is where we're actually seeing a lot of excitement is around allowing you to do things that traditionally would have been very heavyweight from a virtual machine point of view are now lightweight from a container point of view. So I want to show you another thing here. So I'm going to say, OK, create a container. This time, instead of running the date command, can you give me a command prompt? Can you run the bash shell and hang around for a bit? So I'm going to run that, and it's giving me a container. If I jump over to my other session, I'm going to do the same thing again to get a second container. There we go. And now if I jump over to my third session, I can actually come here and I can say Docker PS, which says give me a list of containers. And it's going to tell me you've got 2 containers. They're running bash. You created them a couple of seconds ago. So there's a really interesting thing about these containers, which I'll talk more about this later on. But these containers actually have their own system identity. I can show this to you in 2 ways. The first one is if I show the host name first in the host environment, you'll see this is called Docker demo. If I go to this one, you'll see this has an automatic generated host name that starts 3CA. And if I go here, you'll see, OK, it's got a different generated name. So they each have their own host name, their own system identity. Further, if I look at the network connectivity, this container has 172.17.0.4 as an IP address. This container has 172.17.0.5 as an IP address. And the host has 10.0.0.7. So each of these environments have their own IP address, their own system identity. And so that just kind of gives you an idea of Linux containers. One thing that I also want to show, how big are those containers? I'll talk about that later. One other thing I want to show is actually, and this is one of the things that we talked about in our announcements, was we said we're going to work to get the Docker client running on Windows, the Docker engine running on Windows. And this is something that we've actually already started work on. So the second thing I want to show you is, what do we mean when we say we want the Docker client running on Windows? So one of the big focuses that we have at Microsoft right now is the historic landscape around Windows and Linux has been that these are 2 worlds that will never meet. So show of hands moment. How many people here in their organization have the Windows guys and the Linux guys? Like, let's be honest, it happens. You know, and you know that the Windows guys don't talk to the Linux guys don't talk to the Windows guys, you know, and they both look down on each other, and you know, all that stuff goes on. One of the things that we're investing in from Microsoft is we want to make it so that the Linux guys can use Windows using their tool sets, their concepts, what they're used to. And we want to make it so that the Windows guys can use Linux using their concepts and their tool sets. We want to start trying to break down those barriers. So the work we're doing with Docker is actually an example. So I showed you Docker in a Linux VM at the Linux console. Another way that you can use it is I actually have the Docker client for Windows here. So I actually have a second virtual machine that's running the Docker engine on it, but I can now come to a Windows command prompt, and I can say, same commands, docker run -i-t, Ubuntu, date. And great. You know, in the background, there's a Linux VM, but I'm able to access this from the Windows command line. Now, unfortunately, and this is something we need to work on, if I try and run bash from here, it's going to be a bit of a train wreck. You'll see all gets very weird. This is because there are issues around command prompts handling of Linux terminal emulation. But if I go, there are a handful of third-party consoles that you can get for Windows. ConEmu is one of them, where if I come here, I can do same thing, but this time. And now I get sorts of results I expect. But the key thing is this is a native Windows application that allows the Linux guy to sit down with Windows and interact with containers in this environment in exactly the way that he's used to. So that's a brief demo. So, of course, I hit the wrong button. So I've kind of shown you that, but still, what are containers? We still have lots of questions. Well, there are kind of two answers to this. First, there's kind of the marketing businessy answer to what are containers. And this is the sort of phrasing that my marketing guys would love to use. Containers are a new approach to build, ship, deploy, and instantiate applications. Fantastic. I'm a techie guy, so that means almost nothing to me. So we'll get back to the marketing talk later in this. I'm now going to spend the next 20 minutes going through the computer science answer to this question, because that's the way I view the world. So the computer science answer is, what are containers? They're just another way to isolate processes in an operating system. So the interesting thing here is a lot of people tend to forget that when it comes to the computer science view of this, we actually have a big toolkit of ways to run applications in isolated ways. A long time ago, the dawn of computing, we didn't have multi-process operating systems. You ran a single application and it owned the box. And one of the big advents was like the concept that we would have a process that allowed you to isolate an application, and that we would have threads that allowed you to isolate application. These are just lightweight isolation mechanisms. There are other isolation mechanisms, application virtualization with all the different sandboxes, session virtualization, of course, virtual machines. These are all just tools in the toolbox. But what becomes interesting is when you start looking at, okay, how do I compare these things to each other, and what role do they fill? So I will highlight, I hate PowerPoint animation, but this is an animation that someone on my team did. Usually I pull animation out, but I had to leave this one in because it's so cheesy. So one way to look at this is you could look at it at a spectrum of isolation. You know, you can say, okay, I've got all these isolation technologies, and some provide more isolation than others. You know, so here we've gone, okay, we've got system virtual machines like Hyper-V, VMware, Xen provide the highest level of isolation. Above that, we have containers. Above that, we have application virtualization. That's one way to look at it. You could also look at what's the overhead of these things. How much resource do they use? The reality is there are many spectrums you can look at here. You know, each of these isolation methods have different compatibility statements. They have different security statements. They have different density statements. They have different instantiation time statements. Now, when we have been working on containers and we've been discussing this, a couple of key things to point out. The first thing is, no matter which way you look at it, and there's some shuffles in this, whatever spectrum we choose, it tends to be that containers fall somewhere between sandbox technologies, like app-v, and virtual machine technologies, like Hyper-V. And one of the things that we've spent a lot of time debating on the team is, what are the key things that define the boundaries? And something that I would love everyone here to be really aware of and to be really mindful of is containers are a new and evolving space, and I have no doubt that companies are going to go out there and say inappropriate things. And I'm fairly certain that at some stage, guys in Microsoft Field will be out there saying inappropriate things, and I apologize for that in advance. But I am sure that what we are going to see is we're going to see different companies out there trying to make statements that, oh, like it's only a real container solution if it does X. You know, and because all the competition doesn't do X, then they're not really containers, and we're the only people who actually do real containers. And let me get out in front and say that's all a lie. Just ignore that when it happens. I'm sure it will happen. But what we've been looking at as we've been thinking about this is what actually defines a container. Because the interesting thing is, and we've already seen this, is that there is actually going to be a lot of technology that people associate with containers that aren't defining traits. So a great example is if you look at, okay, let's look at a container versus a virtual machine and say, how do these things handle file system access? Well, virtual machines today tend to treat the file system as a block device. You know, whether you're running Xen, VMware, Hyper-V, we have an image file that's a block device. You know, it's VHDX for Hyper-V, VMDK for VMware. And when you look at the container technologies that are coming out, they tend to be using file-based storage, you know, where their storage is just a folder and the files are there and accessible. Now, these are trends. They're not defining characteristics. If I took Hyper-V and modified it to use file-based storage instead of block-based storage, it would still be virtual machines. And if I built a container solution that used block-based storage, it would still be a container. So what are the defining differences here? So on the top end, what's the difference between a sandbox technology like app-v and containers? Now, this is really important to understand because, you know, to be honest, after the what the heck are containers question, one of the most common questions I've got is, well, how is this different from app-v? And to be clear, yeah, there are going to be scenarios where you could use containers or app-v. But there are a couple of key things that containers have that make them containers and not sandboxes. The first thing is, containers must provide complete application namespace virtualization, which is to say, if an application is running inside of a container, it cannot see other applications on the system in any way, shape, or form. It believes that it is alone in its system. The second part, and this is really key, is containers have a unique system identity. So if you look at sandbox technologies like AppV, yes, they provide a way to package an application. They provide some level of application virtualization to wrap around it. But every application believes it's running on the same computer. They all see the same computer name. They all see the same IP address. Whereas containers all have their own system identity. They have their own system name, their own IP address. So that's a key point. What about the other side? When is it a container versus when is it a virtual machine? Well, it turns out the definition here is really simple. If you can bring your own kernel, congratulations, it's a virtual machine. It turns out that that's pretty much the defining thing about a virtual machine. You can do all sorts of crazy stuff with how you do memory management, how you do storage, how you do networking, all sorts of stuff. If you can bring your own kernel, it's a virtual machine. If you can't, it's probably a container. Containers inherit the kernel and the properties of the host operating system. So, another way to look at this, and I'm going to cover this from a couple of angles because we get lots of questions as people are trying to get their heads around this, is to do a kind of a stack comparison to a virtual machine. So if you look at a virtual machine, which is something that most of us are quite familiar with, the thing you run in a virtual machine is the guest operating system. The guest operating system, its bottom layer before it transitions out of the operating system into the virtual machine is the bootloader. And the interface that the virtual machine exposes up is an x86 system. That's basically the API that's exposed, is all the details of an x86 computer. Now, if you compare this to containers, the thing you run in containers are processes, they're applications. It's not the operating system, it's the application you're wanting to run. Its lowest level is the basic entry point for the application. The API then that a container exposes up is the host kernel services. And that's the boundary and the difference there. So why containers? If this is the technology definition, so containers, a lightweight thing, it exposes the host kernel, it has its own system identity, it's isolated. Why containers? Why would you use them? Well, there are a couple of things. If we look at IT today, and this is actually a great moment to do a show of hands. How many people here would categorize themselves as the guys who own the infrastructure? My job is to deliver compute resource that annoying people do annoying things with. Okay, so how many people would say, my job is to manage and develop the applications that run on the resource that those guys provide? Got a couple of hands? So this is a divide that we see in our users, is we have the people who view themselves as the infrastructure guys, and we have the people who view themselves as the application and the workload guys. And this is something that's been around forever. And when we first came out with virtual machines, a large part of what virtual machines did was they made it a lot easier for these two groups to get along. Because if you go back, way back in the time machine, before virtual machines were around and commodity in our industry, and you remember what it was like in those days, where you would have the guy developing an application or wanting to deploy an application in your environment, and he would realize, okay, well, in order to make this work, I need a new SQL database. And so it'd contact the infrastructure guy and say, I need a new SQL database. And the infrastructure guy would be, great, fill out this 10-page form that does the business justification. Paperwork, paperwork, paperwork. And then he would order the hardware, and 3 months later it would arrive. And a month after that he would have it set up. And a month after that he would tell the guy that he had it set up. And so the reality was that for a lot of people, developing new applications was really frustrating because it would have, like, anytime they realized that they had a new infrastructure dependency, 6 months. And that was the reality. Now, virtual machines changed that because now, one, the infrastructure guy could give the application guy what he needed in a couple of hours instead of a couple of months. That was a huge thing. But the bigger thing that it changed was now, when the application guy asked for a new database server, a new web server, they didn't have to do the paperwork to provide the business justification for this. Because the infrastructure guy had the resource and the capability available. Well, if you think about that, containers then provide the next step along the way. And there are a couple of really interesting things that we're seeing here. The first thing that we're seeing is that containers are so easy to stand up. They're so quick to stand up that we're actually starting to see more and more that the application guy is going like, you know what, I can handle this. I don't need to go to the infrastructure guy in order to do this for development test purposes. He's in charge of production, great, but I can stand this up on my laptop. I can run this. That's fine. Then, on the infrastructure side, containers allow you to be even more responsive, but you can still manage them and orchestrate them and account for them in the way that you do with virtual machines. And the final thing is that we're seeing that this is all feeding into the development of the concept of DevOps. So a quick question. How many people here go like, yes, I know what you mean when you say DevOps? Okay? How many people would say, and we're doing that? Some uncertain hands. So this is really an important area to understand and to start getting your head around. The reality is that if we look at what people are doing with cloud computing today, if you're going to approach, if you're going to continue to approach cloud computing in a manual way, in a way where you set up and you provision and you manage your servers by hand, then I hate to break this to you, you're not going to save much money from here on in. The reality is that where we're at today with cloud computing, if you're doing things by hand, you're not going to save any more money here. Where the next wave of savings is going to come through is if you can start to learn how to automate, how to orchestrate, how to treat your infrastructure like a repeatable, programmable thing. That is where the next wave of efficiency and saving is going to come from. So I'd really challenge, and aside to the whole containers discussion, I would challenge all of you to be thinking about, okay, how can I be starting to think about DevOps and how it can affect my business?
When you look at Microsoft, can you say that Microsoft is leveraging DevOps concept?
Not enough. So the question was, when you look at Microsoft, can you say that Microsoft is leveraging the DevOps concept? It's something that we're working on ourselves. So on one hand, we have our internal development teams are absolutely doing this, but it's not something that we're enabling in our products enough. So for the, our internal development teams are doing this. So a fact that I love is that today, on a daily basis, the Windows Server organization creates and destroys about 80,000 virtual machines in order to do business. And we've been doing extensive automation and orchestration of that. And that's great. Now, the challenge is there's a lot of technology that we're producing where we're not doing it in a way that's enabled for a DevOps workflow. And that's something that we need to step up on and work harder on. So that's the first reason why containers. Oh, that's my only slide, why containers. First time I'm doing this thing. So how do you use containers? How do we see this coming in? Now, before I go into this section, there's something that I want to be very clear and upfront about. I don't know the answer to this question. In fact, today, no one knows the answer to this question. Container technology is still very new. And one of the things that we at Microsoft are trying to figure out is, how are people going to use containers? And there are lots of questions that people ask about, like, well, can I use it here? Can I use it for this? Can I use it for that? And for a lot of these, I go, maybe. Like, maybe that'll work. So what I'm going to do is I'm going to present some of the positions that different people in different companies have had on how do you use containers. But I want to be really clear that, one, I don't believe these are necessarily exclusive. Two, I'm far from convinced that any one of these is definitively right. And three, I'm not presenting the official Microsoft position on this. So, how do you use containers? As a way to deploy and manage applications. There are definitely a lot of people out there who look at containers and go, great, this is just a more secure way to run an application. And you can absolutely use them in that mode. If you think of the demo I showed you, yeah, I ran date in a container. I treated it just like an application, and what I did with it and how I managed it, it was just like an application. However, it had a higher level of isolation, and it was packaged in a more convenient format. So this is one position that people have. As an interesting side note, this is absolutely the way Docker views container technology. They view containers as a great way to deploy and manage applications. And they are. Another way to view them, though, is as a lightweight virtual machine. And this is actually kind of on the other end of the spectrum. And in this view, you go like, you know what? I already manage and understand virtual machines. And containers are just lightweight virtual machines. They start and stop faster. They have some limitations. I can only run the same operating system as the host that they're running on. But I can treat them like lightweight virtual machines. And this is actually a position that's being held from some other open source companies, like Canonical with their product LXD. They're viewing containers as lightweight operating system, lightweight virtual machines. So what's the big difference here, you might ask? Why does this matter? Well, it actually affects how you manage and how you operate them very much. So if you look at the application-centric way of viewing containers, and the demo that I showed you was very application-centric, the only way you can start a container in that world is by specifying the application you want to run. I want to start this container and run this application. And when that application exits, the container exits. They're very closely tied together. When you look at this way of looking at it, then you go, okay, what I'm going to do is I'm going to start up a container before I figure out what I'm going to do with it. And it's going to come up, it's going to have an IP address, I can connect to it over the network, and then at some later point, I can connect to it, I can ask it to run things, and it will run those, and when it's done, it's going to continue to sit around and wait for more things to do. It's very much the way we manage and treat virtual machines today. So both of these are possible with containers. And the reason why I'm highlighting this is, this one I've already seen. I can guarantee you, over the next 12 months, we're going to have companies out there saying, no, the right way to manage containers is as applications. And we're going to have other companies out there saying, no, the right way to do it is as lightweight virtual machines. And I don't think that either of them is particularly right or wrong. I think they're just two different ways of managing it. The final point, though, that I'd like to make on how do you use containers is you actually use them inside of virtual machines. And this is a really interesting point to make. When there started to be a lot of discussion about containers and a lot of people looking at containers, one of the common questions I was getting was, hey, Ben, are containers going to replace virtual machines? Is the future going to be that everything's running in containers and there'll be no virtual machines? And the answer is no, in short. There definitely may be places where it replaces virtual machines, but the bigger reality is what we're already seeing and what we expect to see is that most times, most places, people will run containers in virtual machines. So you may be wondering, why does that make sense? Why would I do that? If I have virtual machines, why am I running containers? Well, there are a couple of things to understand here. The first thing is, this is a strange statement for me to say as to point out the obvious, is the world is now in a place where we virtualize everything. The fact that, and the interesting thing is we're now at a place where people do not explicitly state that that server workload is virtualized because it's assumed that it is. And a great example of this is, and let me tell you, it took me a couple of days to realize this. When I did realize it, I had a slap my forehead moment, but until I realized it, I was actually really angry about it. So when Docker first came out and they were getting a lot of press material, one of the things that they were saying is Docker is great. It lets you write an application once and run it anywhere. And I was looking at that and going man, that pisses me off. And I was doing that on two reasons. The first one is, come on, if any of you have worked in the IT industry for any amount of time, you've heard the phrase write once, run anywhere many times, and you know that it is a promise that is never delivered on. So let's just put that aside. But the second thing was, and the bigger thing was, I was looking at this and I was going, Docker isn't write once, run anywhere. It's write once, run anywhere that there's a Linux 3.8 kernel. And I spent a couple of days going how can they say write once, run anywhere, and how can people believe them when it's write once, run anywhere that there's a Linux 3.8 kernel? And then, the light bulb moment, the slap my head moment was when I realized, actually, wait a second. Thanks to the pervasiveness of virtualization being everywhere in the industry right now, there's nowhere that you can't run a Linux 3.8 kernel. So if you want to run a workload on Linux, great. If you want to run it in Amazon, great. We can get a Linux 3.8 kernel there. You want to run it in Azure, fine. If you want to run it on Windows, fine. If you want to run it on your Mac, fine. In all these places, you can easily stand up a virtual machine, get a Linux kernel, and run your container. And that's actually the story here. And the thing to think about is we're used to going okay, virtual machines are a great, reliable, repeatable platform for moving around. But they're awfully heavy if all you want to move is an application. And so what containers say is, great, you give me a virtual machine that has the right kernel, and we'll package up just the bits of the application that you need. because they have it working and we haven't shipped it yet for Windows. We're working hard. There's no reason. It's just that it's available on Linux today. We've announced that it's going to be available in the next version of Windows Server. There's no architectural thing. It's just we need to get off our butts and actually get the work done and get it out there. So if you look at virtual machines, containers can actually give you a lot more agility, a lot more quick deployment by running them inside of virtual machines. So, okay, fine. But there's another implication to saying containers will run mostly on virtual machines. And let me highlight, because I get a lot of people saying, like, Ben, really? Are you really saying that containers will mostly run in virtual machines? Well, yes, because first fact, like, let's highlight this. We release Windows Server containers, and one of the big things we're going to be talking about is you can do this in Azure, which will be inside of virtual machines on Azure, because if you do anything in Azure, you're doing it inside of a virtual machine. Let me just spell that out. But the second thing is, if we're honest with ourselves, if I deliver Windows Server containers as I'm planning to, and it's part of Windows Server, and technically, yes, you can install Windows Server on bare metal and run containers on bare metal. Let me tell you now, all of you here are going to do it in virtual machines. You just are, because that's the way you use Windows Server. And I don't have to tell you that's a good way to do it. It's the way you're going to do it, because that's the way you run your Windows applications. It's the infrastructure, it's the tooling. So, okay, if you run containers in virtual machines, you get a lot of the agility, you get a lot of the advantages. But it also changes a couple of the pictures. Right now, containers are a very new technology. They don't have the rich feature set that virtual machines have. And it turns out that for a lot of things, that doesn't matter, because you're going to be running them inside of virtual machines. So I can go down the list. The sort of questions that people have asked me is, so Ben, I've been looking at containers, and I've noticed that none of the container technology has live migration. What are your thoughts on that? Well, you should run it inside a virtual machine, because you can live migrate it. Hey, I've been looking at containers, and one of the things they say is the security isn't as strong as virtual machines. In particular, it's not multi-tenant secure. True. So what should we do about that? Well, you should run them inside virtual machines. You know, and there's a lot of things that traditionally we've looked at containers and gone, you know what? I wouldn't use that in a production environment. I wouldn't recommend that. I would rather recommend virtual machines, which it turns out that really the right answer is you want to run these inside virtual machines and get the best of both worlds. So, kind of talk through containers. What is Docker? And this is actually one of the really interesting things. We came out and we announced next version of Windows Server will have containers, and we're partnering with Docker. Turns out it was a terrible thing to announce that on the same day, because, and this is one of those amusing things, is that 99% of the world has the wrong mental picture of what Docker is. Even the people who use Docker on a daily basis. You know, I have pointed this out, by the way, to the people who work at Docker and say, you guys need to do a better job on getting your message out, because no one's hearing it. You know, the reality is, if I talk to most people, and I won't do a straw poll here, but if I talk to most people and said, hey, what's Docker? Their answer is going to be, oh, they're that container thing. Containers. Yes, Docker. Docker, containers, containers, Docker. And that's what most people know and what most people think of. Now, what about if you ask Docker, the company, what Docker is? This is actually their official answer. This is, you can go read this on docker.com, what is Docker? And their answer is, Docker is an open platform for developers and sysadmins to build, ship, and run distributed applications. First thing to highlight, word container is nowhere in there. And And it is really interesting. Docker themselves view containers as a technology that enables them to build something on top of. And they view that they're a platform that just happens to be built on top of containers. And they actually don't view themselves as a container company. So what does it actually look like? So if you get into the high-level architecture, Docker has three main parts. There's the Docker client, and that's what you saw me using in the demo. That's their command line interface for, doing Docker stuff. There's the Docker engine, which is their server-side thing that listens to their client and then is responsible for instantiating containers and doing container management. And finally, there's the Docker Hub. And the Docker Hub is their online part. So when you use the Docker client and you say, Docker run this image, and you don't have it on your computer, it downloads it from the Docker Hub. Drilling in a step further, this is where I get happy. I have to have a block diagram in order to be happy. This is actually a diagram from Docker about what the Docker engine does. And it interacts with all these components inside Linux today in order to create the container and run the workload inside Docker. So once you understand that, let's go back to the announcements that we made around what we're doing with Docker. So we said, first, we're delivering Windows container support in the next release of Windows Server. So let's be clear, that's completely separate from Docker. You're going to be able to use Windows Server containers with Docker, you're going to be able to use them without Docker, just like you can use Linux containers with Docker or without Docker. We also announced that we're going to be providing a Docker engine and Docker client for Windows. And this comes back to what I was saying about allowing Linux people and Windows people to work together better. So by delivering these two components, the engine and the client, it means that someone who's familiar with the Linux tools is going to be able to manage and use Windows containers. Now, a key confusion point that people had when we announced all this is one of the top things I heard is like, hey, you've announced support for Docker on Windows. That's great. That means I'm going to be able to run Linux containers on Windows Server. No. No, 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 no. No, no. That's not what container technology is about. One of the key things of containers is it's running the same OS as the host. What the Docker support means is you're going to be able to manage and work with Windows containers on Windows in exactly the same tooling and style as Linux containers on Linux. So that was a big point of confusion. The next thing we announced was the work that we're going to do with the Docker Hub. This also caused a lot of confusion and a lot of questions about, like, am I going to be able to, publish a Linux thing and pull it down on Windows? And once again, no. This is merely us saying, hey, Docker has this online repository, Docker Hub. We have our own online repository, the Azure Gallery. We should make sure that these things work well together. And we've already made progress on this, where the eventual goal is we want someone who's running Docker to manage their containers, whether they're Windows or Linux containers, to be able to pull containers and packages from the Azure Gallery, just like they do with the Docker Hub. So another partnership, but not an exclusive defining thing. So what else is there? And this is another important point to make. Right now, if you read the popular IT press, you would come away with the impression that, as I said, Docker is containers, containers are Docker, and these two things are synonymous and exclusive. And this is absolutely not true. The first thing, as I've been stepping through, Docker isn't containers. Docker is an application management and deployment engine that happens to use container technology. So already we're seeing a lot of different container management solutions come out for Linux. So the big ones, we've had Rocket announced from the CoreOS team. We've had LXD announced from Canonical. And of course, Linux containers are something that Linux users can script and use without any of these tools. So we are working with all of these companies so that when we release Windows Server containers, you can use the same tools. At the same time, we're fully expecting that, yeah, we're going to see companies coming out and provide management solutions that are built on top of Windows containers. And just like you can use Linux containers without any of these, of course, we're going to deliver an inbox experience that allows you to use Windows containers without an management layer if you don't want to. One thing that is really interesting to call out here, and this is just kind of tangential as an industry observer, when you look at this stack, at the bottom of the stack, you have containers which are an operating system technology. Linux has Linux containers. We're working on Windows containers. We've announced that that's coming out. The next layer up, you have these container managers. And it's kind of strange. The wording I actually used when I first got the relationship between Linux containers and Docker to put this in the Windows world is I went, oh, okay, I get it. Docker is SCVMM for Linux containers. It really is. That's the role they fill in that ecosystem. But the thing that's fascinating that's happening in the Linux world right now is you're seeing an explosion of these these managers that actually run on top of Docker and provide large-scale management of containers. So I've got a list here. We've got Kubernetes, Fleet, Swarm from Docker, Mesos, Panamax. We've got continuous integration tests, Mavens, Jenkins, Shippable, Drone, Fig. Honestly, this is something where the open source community is just going crazy, and we're expecting to see a lot more come out here. So the first thing that's really nice to highlight here is, hey, most of these guys are building on top of Docker, which means when we release Windows Server containers and we have support for the Docker client, all of these sorts of technologies are going to line up. But the second thing to highlight is we're expecting to see a lot more happen here. So as you're thinking about containers, do be keeping an eye on this and watching out for like, okay, who's doing what and how does it make sense? So with all of that, what should you do? Oh, what would be my advice to you guys who are here trying to understand containers and think about containers? So first thing is, keep calm. Seriously, it's not the end of the world. It's fine. As I mentioned, I have a lot of people coming to me and being like, bah, like should I stop what I'm doing with virtual machines? Does this change? To be clear, I believe containers are going to be a revolutionary technology. They're going to change a lot. I think there's a lot of opportunity here. But the world's going to keep on spinning. And we're going to, at Microsoft, we're still investing heavily in virtual machines. And we do not see them going away at any point in time. So if you're ever worried about what's happening with containers, just take a deep breath, take a step back. It's fine. The next thing, and this is a real plea that I would have to you. It's a plea that I've been giving to my marketing team inside Microsoft, is keep an open mind. This is a very new technology area, and it's going to be very easy for you to make conclusions and be like, you know what? Okay, containers work here and not there. So to give a great example, when we first did the announcement around containers, we had a presentation with a bunch of the Hyper-V MVPs, where I got to sit down and step them through largely what I've stepped you through today. Like, okay, here's what a container looks like, here's some of the defining things, here's how it's different, and so on. And that night, I was out at dinner with a bunch of the MVPs, and one of the guys who I know well sat there and said, you know what, Ben, the container stuff, it all looks cool and interesting, but I'm going to stick with virtual machines. And I looked at him and I was like, on one hand, I get what you're saying, but let me tell you, I personally, I run an insane infrastructure in my house because I'm a nerd. And I've personally been looking at my infrastructure and I've been asking myself the question, how many of these do I think stay virtual machines and how many do I think become containers? And there are plenty of workloads where, for instance, I've got a file server that has 5 terabytes of storage and it runs deduplication and a bunch of bells and whistles and so on. And that's a great virtual machine. And turning that into a container really doesn't make sense because I wouldn't really save anything. It's on 24/7. It uses all the resource I give it. If I move that to a container, it wouldn't save me something. On the other hand, and this is not made up, I have a virtual machine in my home infrastructure that is using 1 gig of memory and 20 gig of disk just to run a goddamn SMTP relay. That's all it is, and that is such a waste of resource. And as soon as I can get that sucker in a container, I'm putting that in a container. So keep an open mind. You're going to have different people talking to you about different ways to use containers. Listen, think about how it works to you. The next big thing I'd say is talk to us, please. And I do want to be really clear about this. We're working madly on getting the first release of Windows Server containers out there. We're really excited to get it out there. However, on a weekly, almost a daily basis, as we're working on this, we're having moments on the engineering team where we're getting into discussions where we're like, this facet of the design, like this particular thing, like what's the right thing to do here? And we're having a 3-hour argument, and we're getting to the end of the argument, and we're going, you know what? We just don't know. We're just going to pick something, we're going to put it out there, and we're going to listen to what people tell us about what they're doing and what works and doesn't work. So please, when we get container technology out there for Windows Server, do not look at this and be like, those guys in Redmond, this is their vision, and it either works for me or it doesn't. If when we get Windows Server containers out there, if you play with it and there's something about it that doesn't work for you, talk to us. Let us know. So, I believe that's my last slide. I expect we're going to have a bunch of questions. I have been asked to remind everyone we're going to have an Ask the Experts at 6:45. If you have, it's going to be at main stage. If you have questions, email ask@nicconf. But with that in mind,
What do you think will be the typical workload of containers?
I don't know. I really don't know. What? Absolutely, SMTP relays. I mean, we can look at what we see people doing with containers. A lot of scale-out applications are really attractive. So people doing web tiers, people doing scale-out databases. That's definitely something that we're thinking about, and that seems like a good fit. But in theory, it can run any Windows workload. So it's going to be interesting to see what do people do with it. I don't know. That's one of the things that we're waiting to see and find out. So.
What kind of limitations can it put on a container? CPU, memory, stuff like that?
So, just to be clear, are you asking how can I configure a container?
Limited, so it not only have full access to all the resources.
So most container solutions out there do have resource controls. We're planning to have resource controls on our containers. That does fall into the category of it's actually not a defining thing of a container. That's something we're still working through. So I could give you an answer today, and it might be wrong by the time we get our first beta out there. So we definitely want to provide some form of controls on that.
Do you think there will be system center support for this at launch?
That's actually one of the big things that we're discussing internally. And this comes back to, we don't know how people are going to use this and what this looks like. So we're actually in the middle of discussing, like, is this something that people will manage with System Center? Is it something that they're going to manage through Azure interfaces? What does that all look like? So still a process in discussion. What I'm expecting that you're going to see is that when we release Windows Server containers, which we haven't announced when it is, but we've said that it's part of the next release of Windows Server, and we've said that the next release of Windows Server is coming out next year. So it's obviously sometime in the next 12 months. When we do release this technology, you can expect that we're going to release a whole lot of basic lightweight integration, where we're going to be looking for, like, hey, what do people do? So I could definitely see, and if you take the view of containers as lightweight virtual machines, you could definitely see it fitting into the System Center ecosystem. We're going to be curious. Yeah.
How do containers handle requirements for stuff that doesn't come out of the host system's kernel? Stuff like third-party applications that you might want to use in that container?
So to be really clear, I think what you're asking is, how does it handle third-party kernel mode code? The short answer is it doesn't. And this is actually, if you go and look around forums and discussions of Linux containers, you'll see that, like, yes, if you have Linux applications that aren't using standard kernel mode components, they're not working inside containers either. In order to make container technology work, what we essentially have to do is we have to go through all the kernel mode concepts and make one of two calls, where we either say, by default, that kernel mode thing isn't exposed in a container, or, okay, that needs to be in a container. We need to make that part of the kernel container aware. So a great example for Windows Server containers is we've had to do a bunch of work to make DHCP container aware. Because in order to run containers and so on, you only have one DHCP stack. That's the one in the host. We don't run a separate DHCP stack in each container. But now the one in the host has to be aware that it could have hundreds of entities. Now, in theory, one day we may open up an infrastructure where third parties could make their kernel mode components container aware. That's unlikely to happen in the short term.
What about security in a Windows environment? Does it inherit the same access?
So there are actually kind of two questions there. One that I realized I didn't talk about, and I do want to be really clear on that. One of the, we're 5 minutes over, so I'll try and wrap up in 5 minutes so I can get over to the Ask the Experts. One of the key things about containers and security is, and I'll give you the friendly marketing answer and then the unfriendly engineering answer. So the friendly marketing answer that they like to give is, a key point to understand about containers is they're not multi-tenant secure. That sounds reasonable. The engineering way to say this is, you have to understand with containers, one kernel exploit and you're out of there. And that's the reality. The isolation boundary of a container is the kernel. And kernel exploits are out there. It's a very complicated interface, and any one of those get found, they're going to be ways to escape containers. And we've already seen, numerous reports on Linux containers that, hey, like there are ways to escape. And that's where our positioning is like, hey, if you need multi-tenant security, run these instead of virtual machines. Now, on the issue of SIDs and ACLs that you were talking about, this comes back to the point that I made that each container has its own system identity. So for Windows Server containers, that's going to mean each container has its own SID and has its own identity on the network. It's going to have its own security namespace.
But is it automatically a member of the domain that the host server is a member of?
That's a question I can't answer yet. We're still in the middle of building it, and that's one of the things we're trying to figure out.
In terms of network support, are you going to use bridge networking the same as Linux containers? Or are you going to do something proper?
So the question was, in terms of network support, are you going to use bridge networks like Linux containers, or are you going to do something proper? Actually, one thing that I would highlight is, and this is one of the interesting things, we're spending a lot of time working with the open source community on this, is they have a tendency to move quite fast. They've actually just changed their network model. So Docker 1.5 came out the other day, and if you go look at their network implementation, I think you'll find that it is much closer to something proper. Yeah. So this is, I will be semi-transparent and say this is something where I know the answer, but I'm not allowed to tell you the answer. So I'm going to make some vague statements which you can kind of derive the answer from. So this is fun. Let's see if we can play this game. At Microsoft, we're well aware that in order for a container solution to be viable, it would have to have a full networking solution that worked for enterprise applications and provided sufficient functionality. However, on the flip side, one of the big challenges that we see about containers, certainly, as a side note, I had the Azure guys pulling their hair out when we first started talking about this, is that if you imagine a container platform allows you to create 100 new systems and destroy them in about under 5 minutes, the effect that that could have on a large-scale data center network would be quite catastrophic. So the answer is actually quite complicated because we do want to make sure that we have a solution that works for enterprise applications, but we also want to ensure that we aren't blowing up routers and DHCP servers across the land, which is what would happen if we just took the standard virtual machine network approach. So I'll take one last question and they'll run away. Anyone else? No, everyone's gone quiet, so fantastic. Please do come by Ask the Experts, and if you have questions, please feel free to follow up with me. Thank you.